Now we will discuss upper bound theorem. See, the previous is the lower bound is it's a static theorem. Static laws are applied. Static laws are prevails. Static laws are prevails in this. See, as a basic structure, static laws are prevails. Understood? It's a static theorem. So next it is a kinematic theorem. Sir, how it is? I will show you. This theorem states that the collapse load found by assuming a mechanism will always greater than or equal to the collapse load. What he said that the collapse load is found by assuming a mechanism, that's it, will always greater than or equal to the collapse load. Sir, how it is? Same problem, you can take it. We take it as W. So he said that it's upper bound theorem. A collapse load is found by assuming a mechanism. Sir, what is mechanism? So just think. So mechanism, I said it's the load is increasing. So bending moment, no need of bending moment. See, so already I said it's a bending moment diagram, you already know. At this position is bending moment is increasing if you increase the loading. So once the section gives the full potentiality. What is the full potentiality? MP, moment carrying capacity of MP. So it gives the MP or it reaches that state. It behaves like a what? Hinge. Understood? It behaves like a hinge. So once it forms, it is called a mechanism. It's unstable. Or I said it's unstable. It behaves as a mechanism. So you just see it is previously we applied the load just before the collapse load. Just reaching the collapse load, we taken as a bending moment diagram, take it as. Now we taken just after the reaching the collapse load. Sir, once it reaches the mechanism, what happened? It is formed a hinge. Understood? It form a hinge. What will happen? How it is a hinge, it will go like this, no? That's it, no? It's once it is a form of hinge, it go like this, unstable. Just entered unstable state. It gives deflection. It's a hinge, na? It's a hinge. So without hinge, how it's developed? Without hinge, it will go like this. It will go like this. That's it. Once it is hinge, it will go like this, straight lines. So just after it gives the full potentiality or it reaches to the MP stage, that's it. So just after it reaching this capacity, so you can find out the collapse W. Sir, how can you find out? You can find out, see, so this is W, you can call it as a delta, take it as a delta. It gives the displacement of delta. Okay, so now you can see, this is theta, this is also theta, say. Okay, so now we can see what work done. So we can find out the collapse load by the mechanism laws, not a true structural analysis laws, by the mechanism. So by mechanism or virtual work done. Sir, what is this? See, what is the external work? What is the external work? External work is W into delta, sir. That is, in general, there is nothing happening. We taken as a virtual. Okay, in general, nothing is happening. It's failure means it's failure. Okay, virtual work done. See, what is the external load? Sir, external load is what? W into delta, sir. External work done, not a load. External work done. How much external work done is there? So the load, due to that load, how much displacement is under the load? That is the work done. So internal work done, how the system behaves by this. What is the internal work done? So internal work done, the system moves this delta at this location, the beam turns or gives some rotation. Are understood? Sir, how much rotation it happen? It happens a rotation of how much? This is theta. This is also theta. This total theta. This is 2 theta, na? The, at this location, the structure, how much it is rotated. We already discussed influence lines, everything. We discussed that. So how much it is rotated? This is a positive. So if you taken this is a positive slope, this is a negative slope. So theta, theta of theta. It's a 2 theta is. Are understood? So what is the internal load? Internal work done. Internal work done, not a load. You can strike out. What is internal work done? M. It has a capacity of what, sir? It has a capacity of MP. The moment, that position, that section has a capacity of MP. The section has a moment carrying capacity of MP, and through this, it rotated to theta. Understood? So what is the internal work done? Internal work done is MP, this theta, sir, that theta. Otherwise, you can write like this also. Theta of theta. Okay, that's it, na? That's it. So compulsory external work done should be internal work done. You already know it. No need to discuss it. So W theta is MP 2 theta. So what is delta? What is delta? These are all mechanism laws, not a structural laws. This is L by 2. This is theta. This is delta. So what is delta? Delta is L by 2 into theta. Very small. If it is very small only, okay. Otherwise, this is the law, perfect law. This is all L. This is L theta. You can take very small, very small liquid. Okay. You can apply like this. You can get it now. You can get it. So that's it. If you see W L by 2 theta MP 2 theta. Theta will cancel. So W. So collapse load na. It's a collapse. At this situation, it's collapsed. So that's why we call it as collapse load. So MP, it's 4 by L. 4 MP by L. Got it? Got it. Same value. So this collapse load is greater than or equal to 4 MP by L. Sir, why it is greater than? Say I said just after the formation of the mechanism. Later it will go is increasing. The load is increasing. It is edge just after the formation of the plastic hinge. Just after the formation of the plastic hinge. Later it will go on increasing. If you take a next situation, it's higher. There is no next situations. Just taken like this. Okay. So before that, so see the lower bound theorem. Lower bound theorem we taken as a at this situation before. Are understood? That's why we taken as a from static analysis, static laws. There is no kinematics. Kinematics is moving. Understood? What is static and kinematic? Static is a fixed or steady. Not a steady. It's stationary. Static is stationary. Kinematic is moving. So if this static analysis, we applied a static analysis. By this, it's taken a load. By this, it's a moment. We write it as a, just once if it is reaches to W is 4 MP by L. See, W is less than before this is less than 4 MP by L. Once it is a 4 MP by L, once it is equal to 4 MP by L, it's formation of a plastic hinge. Greater than 4 MP by L, it's failures. So we just did by the static analysis, by this bending moment diagram. Okay, by the bending moment diagram. That's why its W is less than the 4 MT by L. So now it's a kinematic. It's moving. It's unstable. Understood? What is the instability? The structure in the structure, some of the part or total body is moving without any force, or very if you apply a small force, it's moving. It is unstable. It's unstable structure. But we don't take as unstable. Exactly we want what is that situation at that triggering point, triggered point. That's why just later situation. That's why it is a upper bound theorem. Upper bound theorem. So both is getting the same. Are understood? Both you will get the same thing because it just both we assume the same situation, not above, not below, just same situation. Okay, that's why you will get the same answers. You will get the same answers. So now where it is, sir, what we have to consider, static consider or kinematic? If you do in any analysis also, you will get the same value. You will get the same values. You can do by static or kinematic, no problem at all. That is my conclusion. Okay, you can do by static, you can do by kinematic, no problem. Okay, so that's why someone says another theorem also. There is no theorem. There is no theorem. Uniqueness theorem. Uniqueness theorem. What is unique? Just consider those two values. If it is possible to arrive at a system of bending moments for the structure to satisfy equilibrium conditions, a mechanism condition. Now you can see previously it considers previous previously it considers a equilibrium. Equilibrium, these situations are considered. Now the kinematics considers mechanism conditions. Are understood? Kinematics enters into the mechanism, not in equilibrium situations. Just crossed it. Okay. So what is general, sir? Uniqueness theorem. Uniqueness theorem is both combined. So no need at all. There is no uniqueness. You can consider those two values. That is both. If you consider both equilibrium mechanism, both you will consider, that is a uniqueness theorem. Sir, both where it is both, sir. Before the collapse it is equilibrium. After the collapse it is mechanism. Sir, how can you maintain those two exactly? There is no such thing at all. Exactly that location is maintaining the equilibrium mechanism both at a time. He said that like this. So there is no such a situation. We didn't find out at that situation. So that's why you can do by this kinematic analysis or by this static analysis. By using the equilibrium or using the mechanism. Anything just before or just after. You can do it anything. You can got the same answer. That is the uniqueness theorem. There is no uniqueness. Just that is a situation. Not a theorem at all. That's just a situation. Are understood? That's it. Sir, now we can find out another small problems. I will show very simple problems. Okay, very simple problem. Same thing. If the simply supported beam. So see, simply supported beams is determined structure. ds is 0. You require number of hinges. ds plus 1 is 1. Are understood? Once one hinge is formed, that enters into the mechanism state or enters into the collapse state. Okay, so that's it required. So we will do first this type of very simple. So if the same uniformly distributed load is acting, so what will happen? By the static analysis you will see bending moment diagram is this now. Bending moment diagram is WL square by 8. That's it. It is a W if it is W. Same thing. What is static analysis? MP is WL square by 8. MP is WL square by 8 when the load is collapsed load. That load is called a collapsed load. When the W is reaching to WC, the section gives the total full potentiality of MP. So what is the WC? WC is 8 MP by L square. That is a collapse load. But it is, if you taken as a static analysis, you can write as a less than. Sir, very simple, sir. It's not complicated. Complication is coming. Okay. So if we do the same problem, if the same problem in a kinematic analysis or upper bound theorem. So the hinge is formed. Where it is hinge formed? This is by static analysis. There is no hinge formed. Just before the hinge form. Hinge is formed at this location only. You can trace just before. So that's why there is no indication of the hinge at all. Just before. So, but this kinematic analysis, hinge is formed just after upper bound theorem. Kinematic analysis. Okay. So just hinge is, where it is hinge formed? Hinge is formed at the maximum bending moment location. So I will say hinge, plastic hinge is formed. Where are the locations? Locations are maximum bending moment. The first, you have to remember first. Second is cross section changing. If anything, cross section is changing in between the section or in between beams, there is also chance to form a plastic hinge at that location. Cross section changes. So maybe if there is a cross section like this, if this is the beam, maybe this is the center point. If this is the center point, but there's somewhere L by 4, its section is changing. In this location also maybe chances are there. It is the maximum bending moment applying section is there, but maybe chances are there when the cross section is changing. Okay, we have to check it. Later we will see. So just remember first. Now you can remember plastic hinge is formed at maximum bending moment location. Cross section changing locations also. We'll see later. Okay, we will do problems. So now we will see. In this situation, there is no cross sectional change. Maximum bending moment location is center. So at that location, hinge is formed. You can fix it. Hinge is formed. Hinge form. That's it. Hinge is formed. This is so this is delta. You can take it as this is theta. This is theta. So this is the moment carrying. This is the MP. Understood? This is the hinge. This is the hinge form. So what is the work done? This is theta. This is theta. Both are same because uniformly distributed load. So both thetas are same. Okay. So what is the work done? Internal. Internal you already know. MP, plastic moment capacity of the section, this section, multiply with theta plus theta, you already know. What is external work done? Sir, there is no load at that location, but we have a load at throughout. So this load has this much of displacement, this load has this displacement, this load has this displacement. So total, what is the work done? Load and multiply with displacement. So total load multiply with total displacement. How can you get it? You will get it area. Are understood? So we did it in uniformity. Influence lines also same thing. Na? We get it by the just area. Are understood? We get it by the area. So what is the area? So what is work done? W. What is area? Area of this total diagram, that is total W. So this W per unit load, na? W per unit meter. So this is a W that has a displacement. Understood? I will again say this is a W per unit meter, na? So that is taken 1 meter. This is W, this has displacement. This is 1 W, this has displacement. So total load multiply with total displacement. So you will get total area. It's integration. Na? It's integration. We did so many times. No need to discuss again. Okay. So what is that area? What is that area? Sir, half into delta into L. That's it, na? Half into half delta L. That's it. That is the area, na? That's it. So now you can see what is that area of what is delta? Delta you can say same thing. Previously you can say it is this is delta, this is L by 2. So delta is L by 2 into theta. L by 2 theta. This is L. So this is MP by 2 theta. So what is that? Theta will cancel. We need, this is a collapse load, so that's why we have to include C. So MP 2 is a, what is that, 4 4 to the 8 8p. So L L L square, sorry, it's excellent, it is excellent, WL square. So what is WC? 8 MP by L square. Got it? Got it. This is upper bound theorem. That is. Got the idea? So when the load reaches to this value, when the load reaches to WC, what is that WC, sir? 8 MP by L. What is MP? Plastic moment capacity of the section. That section plastic moment capacity. If the rectangular or circular anything, if the rectangular, it is capacity of PD square by 4. The circular, you can calculate it. The circular, you can calculate anything. So not a circular and also I section, anything we calculated. What is the MP value of that section? If the load is reaches to that value, the section is, the structure is collapsed. Got the idea? So that is the upper bound theorem and lower bound theorem. Static theorem, kinematics, equilibrium, mechanism. Got the idea of these words? These are the words, only words in the plastic analysis, nothing more than this. Plastic zone, elastic zone, elastic zone, plastic zone, upper bound, lower bound. So static, kinematic, equilibrium, mechanism. Okay, those are the words. That's enough. So the same thing now you can see. We will do another problem. No need of another problem. If it is W, if it is A, this is B. Total length is L. So what is that? I will do in both. Now later it's a kinematics is easy. Not a statics is not easy. So what is that value? This value is WAB by L. You already know it. It's a kinematic. So what is MP? MP is WAB by L. So what is the collapse load? Double MP L by AB. That's it, na? MP AB by L. See, MP L by AB. It's easier, na? Easier. So now I will show you in the same in the kinematic analysis. Kinematic analysis. So W. So hinge is formed. So that's failure load. Hinge is formed. That's it, na? It is delta. This is AP. This is a moment carrying capacity of MP. Okay. So now you can see this theta is different. This theta is different because lengths are different, na? Both thetas are different, na? So you can take it as this theta, this is alpha or anything. So if you consider this is, if it is considered, this is alpha, this is theta, this is theta. Okay. So now you can see what is the internal work done. Internal work done is, you already know. What is work done? External work done. External work done also, that is delta. Already know it. That's it, na? So we have to change it. Change it. Change it. Sir, how can you change it? Sir, see. One thing you can see first. It is A, this is delta, this is theta. Now what is delta? Delta is A theta. In the same manner, this is alpha, this is B. Delta is, you can call it as B into alpha. You can call, so A theta is equal to B alpha. Understood? A theta is equal to B alpha. So you can write it as alpha is equal to A theta by B. Alpha in terms of theta, theta in terms of alpha. You can write it as anything. So now you can see MP theta A theta by B WC. So delta, you will write it as an A in terms of A theta. A theta. So MP, so what you will get? B theta A theta by B WC A theta. So B theta plus A theta. Theta is common, A plus B. A plus B is what? A plus B is L. M plus B theta divided by B is WC A theta. Theta theta will cancel. What is WC? MP L by AB. Got the idea? It's upper bound theorem. You feel that sir static theorem is very easy, nothing more to discuss. Kinematics is easy, not statics. Okay, we will see later. So that's it. Now these are all determinate structures. DS is 0. We required plastic hinges are D plus 1. One hinge is required at this acting at the maximum bending moment location or cross section location. We will see later. Okay, now we will see next level. Next level is only one. Indeterminacy is 1. Required number of hinges is 2, but that is somewhat small difficulty is there. So that's why we'll directly do the fixed beam. Are understood? Small difficulty is there, I will show later. So directly I will show this. This is a fixed end beam. Sir, what is the kinematic? Static kinematic, sir? 3, 3, 3, 3. Consider 3, 3, it's 3 minus 3, 6 minus 3, 3. When horizontal loading is also there, so just delete the horizontal loading. Horizontal load is there, not there, just fix it. So only vertical load, so moment, vertical load, moment. So 4. Okay, just 4 and equilibrium also, equations also you can delete the horizontal. Sigma x is equal to 0, delete it. 2. It is a indeterminacy of 2. We already know it, no need to discuss. So it is indeterminacy of 2. That means we require 2 plus 1. 3 hinges are required to enter into the mechanism. Unstable situation, kinematic situation. Or got the point? So situation. Now I applied a load at center. Got the point? So you already know what is the bending moment diagram. So these are the fixed end moments. This is WL by 4. Fixed end moments, not WL by 8. Sun. So this is negative. This is collapsed. Okay. This is positive. This is what you are? WL by 8. This is also WL by 8. You already know it. So this is the bending moment diagram. So now we can observe internal meaning. So see, the load is increasing. This is WL by 8. It's a hogging moment. It's a sagging moment of WL by 8. Sagging moment, hogging moment, sagging moment. So now you can see where the first hinge is formed. The first hinge is formed which section got the maximum loading. Sir, here is exactly all similar, sir. So that's why I will do this. I will feel this. If it is loading like this, the section this fixed joint got the maximum moment. So if the load is increasing, the first hinge is formed at this location because it gets the maximum bending moment. So that's why it reaches to the MP state. First it forms the MP. So first the hinge is formed here location. Later where another moment is, where the maximum bending moment acting at another location. So you can take it as this location. So next MP is formed here. So once it is formed as a hinge, it is a MP, it reaches to the MP, it is a hinge. But if you form the hinge here, there is no enters into the mechanism because it is like a hinge, it is a fixed joint, the load is acting. It is a proper cantilever. It is also it has also one indeterminacy. Again the load is increasing. It reaches to the MP state. So now it is formed a simply supported beam. It is also forms a simply supported beam. There is no determinacy, but it is following a static theorem. It's not enters into the mechanism. Later, if you increase again, Then somewhere where the load is maximum bending moment is acting at that location, extra hinge is formed. At that situation is collapse. I got the point. So that is the situation, but don't need it. So don't need it all. Now we can see. Now we can see. Observe it. Here, if you see here, everything is same. This is the maximum. This is WL by 8. This is also WL by 8. So the three hinges formed at a time. Got the idea? Three hinges are formed at a time because every maximum bending moment locations has the same bending moment. They are increasing the same order. The three hinges are formed at a time. The load is not at center. The situation is different. The first hinge is formed at this location. Second is formed at this location. Third hinge is formed at where the maximum load is acting. But here the three hinges are formed at a time. So now you can see no need of these things. This moment carrying capacity of MP at this is a hinge. Just before I said, just before it reaches to the capacity of MP, it reaches to the capacity of MP. At this location also moment reaches to the capacity of MP. Understood? So that's it. That's it. So sir, how can you find out the carrying capacity? So now you can see. Now you can see. By the based on the bending moment diagram, you can easily say it, sir. Sir, see. The same diagram I will write like this. You will already know it. You will already know it. Okay. So this is, if it is loading is acting like this, if it is acting at some W, this is WL by 8. This is also WL by 8. Okay. So now the situation is, this is acting bending moment. Acting bending moment. So capacity is reaching to this location is MP. This capacity also reaching to the location of MP. MP. Are understood? So now find out. This is MP. This is also MP. This is also MP. So now you can see this is 2 MP. Are understood? So now you can write it. 2 MP is equal to the, what is equal to the? So 2 MP is equal what? 2 MP is equal WL by 8 plus WL by 8. This is acting moment. Are understood? This is acting moment. This is WL by 2. See, WL by 8 is acting at that location. So if you are acting WL by 8, it reaches to the MP. The same thing here also, it acting as WL by 8 is acting. Is equal to the MP. WL by 8 is acting equal, WL by 8 is MP, WL by 8 is MP. WL by 8 is acting bending moment, MP is the resistance. So if you applied WL by 8, this is a collapse load. So W is taken as a collapse load. If you are acting WL by 8, it reaches to the MP. That's it now. So if it is C, if it is the different situation, if it is different situation, if it is lacking acting, so what is the bending moment diagram? Bending moment diagram is, this is the bending moment diagram. Got the idea? So now you can see this is the, what is the value. You have to find out the bending moment at that location. You have to find out this is the bending moment diagram. This is also 1 MP. This is also MP. Are understood? So now you can find out. So I will show you. I will show you later. Not later, just nowadays. Okay. So now you can see what is MP. What is MP? That is not very simple. It's WL by 8. Are understood? So what is WC? Is less than static intensity. WC is what? 8 MP by L. This is easy. Okay, this is okay. So now same the situation. Now same situation you can see. The same situation. WC kinematics. We can analyze it to kinematics. Okay, we will analyze it into the kinematics. So now you can see. Now you can see Plastic hinges are found where it is formed. This is a one plastic hinge. This is one plastic hinge. This is one plastic hinge. Three plastic hinges are understood. Three plastic hinges are formed. So then only it enters into the mechanism. If only two hinges are formed at this location, it is a simply supported beam, not enters into the mechanism. So those three hinges are formed. What will happen? It will go like this. Other? Exactly? Exactly. This is delta. So now you can see what is external load? External work done? WC into delta is okay. What is internal work done? Internal work done you can just see is imagine. This is theta, this is theta, this is theta. This is a plastic hinge capacity of MP. You already know MP, this theta, this theta. This is the work done of this hinge. And you can include it. It is also reaches to the MP na. It is also reaches to the MP. At this location it develop a rotation of theta. Sir, previously why don't you include it? Previously at the starting only it has a only zero moment carrying capacity because it is a simply supported. There is no internal work done required to rotate it. Sorry. Understood? Previously only hinge is formed here and it is rotating like this. This hinge is turning the section. There is no internal work done here because it is a previously at the starting location it is a hinge. It can easily rotate it. No need of external internal work done. But now it's a fixed beam. It reaches to the MP and it converts to the rotation. Understood? So that's you have to include it. That is the internal work done. So include this value. What is that value? MP theta. Include this value. This is also MP na? Section MP. That section reaches to the MP and rotate theta. Got the idea? So what is delta? You already know delta is. Delta is L by 2 into theta. This is 2, 3, 4. 4 MP theta. Theta theta cancel. What is WC? Is greater than 8 MP by L. Got the idea? That's it. That's it, na? That's it. Now you can see the same previous problem I said. I will give the same example. Another example. The load is acting at this location. So this is A, this is B. What is the bending moment diagram, sir? Bending moment diagram is we already know what is the bending moment diagram. This is okay. So later that's the bending moment diagram. So what is this? W A B square by L square. It is W A square B by L square. Now we can see, just see it is. At this location it reaches to the first MP. So at this location it reaches to the MP. Later at center also it reaches to the MP. Center, what is the bending moment? This is the bending moment. This is collapsed. Positive negative is collapsed. Otherwise you can write the same diagram. Okay. So this is the bending moment. You can write. Okay. So now we can see this reaches to the MP. This is also MP. Resistance. This is also MP. Are understood? This is also MP. This is also MP. So what is the bending? What is the exactly collapse load? So collapse load is what? So see, so what is collapse load? Collapse load, how can you write it, sir? So see, how can you see? Just observe it. This is MP. This is also MP. So this value is this value is we don't know. Sir, at somewhere at middle. How can you find? If you know, if you find out, just to find out that value. This is 1 MP, this is 1 MP. You can add 2 MP is equal to this value and this value. Because, sir, this is also equal to MP, you can find out. Sir, no. Because failure is happening at the third hinge is happening. Okay, not a first hinge. So only one hinge is happening, MP is equal to this value. Second is happening, MP is equal to this value, you will got MP. No. At the third hinge is happening, then only it reaches to the failure point. Sir, up to what? So once it reaches to the MP, next if you increase the load carrying capacity is not increasing, it is full, gives the full capacity. Sir, if you increase further the capacity is increasing here. In this here, it's no longer to give any resistance. It behaves as a hinge. It steadily stay there like a hinge. No failure, just a hinge, it is. Okay, now we can see what is this value. So that's it. If you write down like this diagram, it is easier. You can understand. So how can you understand? See. So this is reaches to the this is reaches to the MP. You already know it. This is also MP. This is also MP, na? That is also MP. At that location, it gives the resistance of MP. Sir, what is this value? Applied, what is this value? What is this value? Sir, we don't know, sir. We know this value, but we don't know this value, sir. But we know what we know. We know this value, total value. Sir, how can we know, sir, total value? Total value is this value, sir. If you see, this is the, what is this total value? This total value is, what? WAB by L. Understood? This total value is what? This total value is what? This total value is WAB by L. Simply supported beam. In the fixity is arising, that's why it is something negligible. Its total value we know it. This is we don't know, this is we don't know, but total is WAB by L. Are understood? And got the point? WAB by L. So if you write down like this diagram, you can understand now. This is MP, this is MP. The total is WAB by L. So now you can write it. Now you can write it. What it's are? This is total is 2 MP. This is MP, this is MP. Is equal to the WAB by L. Understood? So what is WC? 2 MPL by AB. That's it. That is the failure. Don't consider this value. This is also equal to AB. This is also equal to MP. This is also equal to MP. But it's not reaching to the failure. We have to take care of all things. That is called static theorem is somewhat it's going to be difficult. Next by next, it's going to be difficult. We can't give the direct bending moment diagrams. We don't know the bending moment diagram values. If you know the bending moment diagrams only, we can find out the what is MP value. That is I said previously. So if you see the static analysis theorem, a load determined on the basis of any assumed collapse bending moment diagram. Bending moment diagram only in which the moment of any section is less than the plastic just before. So it requires bending moment diagram. If you know the bending moment diagram only, you can find out the collapse load. Are understood? So, but in kinematic analysis, no need of any bending moment diagrams. No need of any bending moment diagrams. Can I show you? Same thing, just see it. Just see it is. WC, it's a collapse, it reaches to collapse. I said it's a first the bending hinge is formed here, later hinge is formed here, later at the under the load. So it will give maximum bending moment. So at that location hinge is formed. So now you can write down, draw a mechanism. This is delta. This is what theta, we don't know. This is alpha, compulsory both are different. Okay, so this is alpha, this is theta, you can write down this is theta. Okay, so what is the external work done? External work done W into C, if you call it as AB. So previously what we discussed, same thing again. This is alpha, this is theta, this is AB delta, A theta is delta, P alpha is delta, we already write now. So A theta is equal to P alpha. So for alpha, A theta by B, you can write it. So what is internal work done? Internal work done is this has a plastic hinge MP into theta into alpha. This is second, see, this is reaches to the plastic hinge, it has a capacity of MP, it rotates alpha, MP into alpha. It's first is MP multiply with theta. Got the idea? So that's it. Now you can see how much it is, how it is. WC, you can delta, you can write as a theta. So MP theta, you can write same theta. Alpha, you can write A theta by B. MP alpha, you can write A theta by B is MP theta. Okay, so write down MP B theta plus A theta is L theta. L theta by B. MP A theta by B. MP theta. A theta. Theta theta, you can cancel it. You can cut the cancels. Cancel. And also you can substitute MP, you can outside L by B, A by B plus 1. Okay, so how can you write it? You can substitute L plus A plus B by B. A plus B is what? A plus B is again L. So you can write as AP is a 2L by B. WC into A. So what is WC? MP 2L by AB. That's it. Got the idea? So if you reach that load, this value, then only the system is collapsed. That is a collapsed load. Every section, not every section, the hinges location, at least required 3 hinges are required. At least required 3 hinges, 3 plastic hinges are formed, should be formed. The plastic hinge has a capacity of MP. Understood? The plastic hinge capacity is MP. It develops at anywhere. Understood? I said it. Once again I will say, see, it develops here, its capacity is MP. Here it develops, it's also its capacity is MP, because the failure point reaches when it reaches to MP only. Don't confuse by, sir, this bending moment is small, sir, compared with this, so it is less than MP. No, one is applied, one is a capacity. That is should clearly differentiate between those two, applied and a capacity. Understood? This is a capacity, this is a applied force. If you apply it, it will give the bending moment diagram like this. It is increasing like this. Once this location reaches to the hinge point, once it reaches to the hinge point, later it reaches to the hinge point, plastic hinge develops, later it will reach this hinge, later it will reach hinge. Okay, understood? So that's why it's increasing, the section is reaches to the MP. The bending moment diagram is simply same thing, because the distribution is same na. The distribution is same up to failure. Up to failure, the distribution is, if load is increasing also, it will give the same bending moment diagram. The W is changing, that's it. Bending moment is WL by 8 something, W same thing. Understood? Bending moment diagram is same up to the failure. Once it's failure, system enters into the mechanism. Just before the failure, just after the failure, we did 2 analysis. That's it. We just 2 analysis. Just before, just after. Just before, it follows the same. Up to the bending static analysis, it follows the same. It gives the bending moment diagram like this. We thought at this location it has a capacity of MP. It has also capacity of MP. The capacity is 2 MP is equal to this applied moment. That's it now. Applied moment and its capacity. Capacity it reaches MP it reaches. So capacity and resistance. Capacity and applied. Or resistance are applied. Here it is very easy. Just simple. It's very simple. You can, if you have any values are there, it is very simple. Kinematic analysis just after. After it follows the only mechanism. Not any static laws. Static equilibrium laws. No. No static equilibrium laws. Internal work done, external work done, we have to do this. Okay. So next class we'll see the proper cantilevers. It has only one intimacy. We require two hinges are required. So how it is, where it is, we'll see later. Beams are we later beams. Okay, later beams.